Hi students, welcome to your channel. Please like, share and subscribe your own channel, School Studies. School Studies is pleased to announce the launch of our educational website, Patel Section. After years of hard work and dedication, we are delighted to officially announce the launch. Our goal with this website is to provide our students with an easier way to learn the lesson and prepare for exams. Do visit our website for the more information and knowledge. Today we will see a video related to NCERT Solution for Class 9 Mathematics, Chapter 8 Quadrilaterals Exercise 8.2. So let's solve textbook exercise. The first question is, ABCD is a quadrilateral in which P, Q, R and S are midpoints of the sides AB, BC, CD and DA. AC is a diagonal. Show that SR parallels AC and SR equals to half AC. In triangle DAC, R is the midpoint of DC and S is the midpoint of DA. Thus, by the midpoint theorem, SR parallel AC and SR is equal to half AC. Next, you have to prove PQ equals to SR. So, in triangle BAC, P is the midpoint of AB and Q is the midpoint of BC. Thus, by the midpoint theorem, PQ parallel AC and PQ is half AC. Also, SR equals to half AC. So, we can cut half AC, half AC to it will become PQ equals to SR. Next, we have to prove PQRS is a parallelogram. So, SR parallel AC from question 1 and PQ parallel AC from question 2. So, SR parallel PQ from question 1 and 2. Also, PQ equals to SR. So, PQRS is a parallelogram. Next, second, ABCD is a rhombus and PQR and S are the midpoints of sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rectangle. So, in the question, given in the question, ABCD is a rhombus and PQR and S are the midpoints of the sides AB, BC, CD and DA respectively. To prove PQRS is a rectangle, so construction, join AC and BD. So, we will join AC and BD. Proof, in triangle DRS and BPQ. DS and BQ, halves of the opposite sides of the rhombus. Angle SDR and angle QBP, opposite angles of a rhombus. DR equals to BP, halves of the opposite sides of rhombus. So, triangle DRS congruence triangle BPQ, SAS congruency. So, RS equals to PQ by CPCT. This is our first result. In triangle QCR and triangle SAP, RC equals to PA, halves of the opposite sides of rhombus. Angle RCQ equals to PAC, opposite angles of a rhombus. CQ equals to AC, halves of opposite sides of the rhombus. So, triangle QCR congruence triangle SAP by SAS congruency. So, RQ equals to CP by CPCT, that is our second result. Now, in triangle CDB, R and Q are the midpoints of CD and BC respectively. Therefore, QR parallel BD. Also, P and S are the midpoints of AD and AB respectively. So, PS parallel BD, QR parallel PS. So, PQRS is a rhombus. Also, angle PQR equals to 90 degree. Now, in triangle PQR, RS equals to PQ and RQ equals to SP from 1 and 2. Therefore, angle Q is also 90 degree. So, parallelogram PQRS is a rectangle. Next, ABCD is a rectangle and PQR and S are the midpoints of the sides AB, BC, CD and DA respectively. Show that quadrilateral PQRS is a rhombus. So, it is given from the question that ABCD is a rectangle and PQR and S are the midpoints of the sides AB, BC, CD and DA respectively. First, we will join AC and BD. To prove PQRS is a rhombus, we First, take in triangle ABC, P and Q are the midpoints of AB and BC respectively. PQ, parallel AC, and PQ is half of AC, midpoint by the midpoint theorem. This is our first result. In triangle ADC, SR parallel AC and SR is half of AC by midpoint theorem. This is our second result. So PQ parallel SR and PQ equals to SR. As in the quadrilateral PQRS, one pair of opposite side is equal and parallel to each other. So it is a parallelogram. So PS parallel QR and PS equals to QR. Opposite sides of parallelogram. This is our third result. Now in triangle BCD, Q and R are midpoints of side BC and CD respectively. So QR parallel BD and QR equals to half BD by midpoint theorem. AC equals to BD because diagonals of a rectangle are equal. So from equation 1, 2, 3, 4 and 5, we can say that PQ equals to QR equals to SR equals to PS. So PQRS is a rhombus. Next, ABCD is a trapezium in which AB parallel DC and BD is a diagonal and E is the midpoint of AD. A line is drawn through BE parallel to AB intersecting BC at F. Show that F is the midpoint of BC. Now it is given that ABCD is a trapezium in which AB parallel DC and BD is a diagonal and E is the midpoint of AD. To prove F is the midpoint of BC. This is the BC, F is the midpoint of BC. Proof, we have to prove that BD intersected EF at G. So in triangle BAD, E is the midpoint of AD and also EG parallel AB. Thus G is the midpoint of PD, converse of midpoint theorem. Now in triangle BDC, G is the midpoint of BD and also GF parallel AB parallel DC. Thus F is the midpoint of BC, converse of midpoint theorem. In a parallelogram ABCD, E and F are the midpoints of side AB and BCD respectively. Show that line segment AF and EC trisect the diagonal BD. So it is given that ABCD is a parallelogram, E and F are the midpoints of the sides AB and CD respectively. To show AF equals to EC trisect the diagonal BD. So first we will take ABCD is a parallelogram, AB parallel CD, also AE parallel FC. Now AB equals to CD, opposite sides of parallelogram ABCD. So half AB equals to half CD. AE equals to FC, E and F are the midpoints of side AC, AB and CD. AECF is a parallelogram, AE and CF are parallels and equal to each other. AF parallel EC, opposite sides of parallelogram. Now in triangle DQC, F is the midpoint of side DC and FP parallel CQ as AF parallel EC. P is the midpoint of DQ. Converse of midpoint theorem we have used here. DP equals to PQ, that is our first result. Similarly, in triangle APB, E is the midpoint of side AB and EQ parallel AP as AF parallel BC. So Q is the midpoint of PB, converse of midpoint theorem. PQ equals to QB, that is the second result. From first and second result, we get that DP equals to PQ equals to BQ. The line segments AF and EF trisect the diagonal BD. Hence it is proved. Next, show that the line segment joining the midpoints of the opposite sides of quadrilateral bisect each other. So let ABCD is a quadrilateral and PQR and S are the midpoints of AB, BC, CD and DA respectively. Now in triangle ACD, R and S are the midpoints of CD and DA respectively. SR parallel AC. Similarly, we can show that PQ parallel AC, PS parallel BD and QR parallel BD. So parallel PQRS is the parallelogram, PR and QS are the diagonals of a parallelogram PQRS, so they will bisect each other. Next, ABC is a triangle, right angle at C, a line through the midpoint M of a hypotenuse AB and parallel to BC intersect AC at D. Show that D is the midpoint of AC. So in triangle ACB, M is the midpoint of AB and MD parallel BC. D is the midpoint of AC. Converse of midpoint theorem. MD perpendicular to AC. So in angle ACB equals to angle ADM, corresponding angles. So ACB angle is 90 degree. So ADM equals to 90 degree and MD perpendicular to AC. CM equals to MA equals to half AB. So in triangle AMD and triangle CMD, AD equals to CD, D is the midpoint of side AC. Angle ADM equals to angle CDM, each are 90 degree. DM equals to DM, they are the common line segment. So triangle AMD congruence triangle CMD by SAS congruency. So AM equals to CM by CPCT. Also AM equals to half AB. M is the midpoint of AB. Hence CM equals to MA equals to half AB. So this was exercise 8.2 of NCERT solution for class 9th mathematics. I hope you liked my video. Thanks for watching my video. Thank you. Please leave comment, question or doubts in comment section if you have any, or you can drop a mail to us. You will find my email ID at the end of this video. You can also join us on Facebook page, follow us on Instagram, connect us on LinkedIn or tweet us on Twitter. Thanks for watching my video. Thank you.